ID code 16550, lowest common ancestor of a binary tree 3. It is given two nodes of a binary tree P and Q. Find their lowest common ancestor. Here, the tree nodes, it has some kind of variables like value in the left, right. It also has a variable called which has a node type called parent, and this get our problem much easier. And take the example of the first one. The P is 5, Q is 1. Let's find their common ancestor is 3. And the next example for 5 and 4, and the common ancestor is 5. So for this question, it says that all node values are unique, and also P and Q always exist in the tree. So there is a pretty simple. We can use a set to do this kind of question. And when we go through the every node, for example, the node P, and iterate from P's value to its root, its parent value until it reaches the root. How can we know that the node reaches the root? Is that for that node it does not have a parent node. So we can use the set. For example, if in a tree we have P is 5, right? Let's take P as the 2. Take this one. We use a set to put every value into when it iterate from going to its parents node until it's reach to the root. And for Q, we do the same thing. If when for the Q node, we trying to go to the parent. If we find a node which have the value already exist in the set, in the P set, then that will be its common ancestor. So let's write code. We are going to use set integer new set. We are going to, from the P node, trying to put its value to its the path from its value to the root, the node's value into the set. And let's just try to write while P doesn't equal to now. P equals P dot parent. And we are going to also put the set at P dot value. And in the meanwhile, we are going to iterate the node Q while Q doesn't equal to now. I will also have the Q to go up, Q dot parent. So let's say if that contains P dot Q dot value, then return Q. And if we for this question, it will always have value, but in order it to be able to compile, we have a return possibly none in the end. P dot var. Okay, so for this question, let's say the time complexity will depend on the tree's height. Also, for the space complexity, we use a set that is also dependent on the tree's height. Normally, we'll say they are both OH, depending on how balanced is the tree.